Okay, so in this problem, what we want to do is we want to show whether this triangle here does form a right triangle or not. Okay, so there are three steps in doing this. Number one is we want to plot each point. So we have A -2, 5, B 12, 3, 10, and C 10, -11, right? So those are the 3 points we have. So we're going to plot those, in which I already did. Okay. Then what we're going to do next is step two. Once we plot this, then we need to calculate the distance of each of these line segments of the basically the size of this triangle. Okay, so we need to find distance of AB, distance of BC, distance of I should say AC, not AD. Okay, distance of AC. Okay, so we do that by using the distance formula. Once we find the distance, okay, then we need to use the Pythagorean theorem to show whether it is or not a right triangle. If it is a right triangle, then we go on to the last step, okay, which is to find the area of the triangle, right? So first, let's go ahead and calculate the distance of each of these sides of the triangle. So first one is I'm going to calculate the distance between A, B, all right? So I'm going to label this as x1, y1, x2, y2. Okay. Now, again, I can make B x1, y1 and A x2, y2. It doesn't matter. In the end, we'll get the same answer. But I kind of just like to have it in order. First one was given to me, so I'll label that x1, y1. B is given to me second, so I'll label that x2, y2. Okay. All right, then what we're going to do is we're going to put these numbers into our distance formula. Okay. So x2, that's going to be 12. X1 is going to be -2. Notice I have two negatives here. So I have the minus. I always have a minus. We're always subtracting the two coordinates. Then we have another negative here for the -2. And then for y2, we have 3. And y1, we have 5. Okay, so we want to square those, square those. Okay, so let's go ahead and simplify this and see what we get here. So again, two negatives makes a positive. So that's going to give us 12 plus 2 square, which is going to be 14 square. All right, which will give us 196. Okay, over here, we're going to have a -2 square. -2 times -2 is going to give us a positive 4. Right? So again, all of this is still under the radical. Okay? Still under the radical. Right? Under the radical. So we're going to add those. Okay? So the square root of 196 plus 4, that's going to give us square root of 200. All right? So that's going to be the distance of AB. But of course, we want to break this down and simplify this. So for the radical 200, I can break that down as 100 times 2. Because again, 100 times 2 is 200. And I can break that radical into square root 100 times square root of 2. Well, square root of 100 is 10. And then radical 2, that's already in simplified form, so I just leave it alone. So that's going to be 10 radical 2. Okay. So that's the distance of AB. All right, so now what I want to do is I'm going to go through the same process, but this time I'm going to do it for BC. Okay, so I already have, so again in our graph, that will be, looks like the bottom of this triangle here. Okay, BC. So I'm going to label this as x1, y1, x2, y2. Okay, and then start plugging them into my distance formula. So x2 is going to be 10, x1 is 12, and that's being squared here. Y2 is -11, and y1 is 3 squared. Okay. All right, so 10 minus 12 is going to give me -2, which is still squared. And -11 minus -3 is going to give us -14, which is squared. So -2 squared is 4, and -14 squared is 196. Okay, so again, these are still under the radical. So 4 plus 196 is going to give us radical 200. Right? And again, like this, what we did last time, we can break this down to radical 100 times 2, and that'll be radical 100 times radical 2. So radical 100 is going to give me 10, and radical 2 is going to be the same. Okay. All right, and then we need to do it for AC. All right, so again, I already have my coordinates here listed, so I just need to apply the distance formula. So I'm going to label this x1, y1, and then x2, y2. Okay, so we have x2, which is 10, minus x1, which is -2 squared. Then we have y2, which is -11, minus 5 squared. Okay. So two negatives is a positive, so it's going to give us 12 squared, and then -16 squared, all under the radical. Okay, so 12 squared is going to give us 144, and -16 squared is going to give us 256. So when I combine those together, we're going to get radical 400. Okay, and then I can break this down to radical 4 times 100 inside, right? And then this can be broken down to radical 4 times radical 100. Radical 4 is 2, radical 100 is 10. So 2 times 10 will give us 20. All right, so we've found all our lengths. So now we just need to transfer that information to our graph. So again, for distance AB, we got 10 radical 2. For distance BC, we got 10 radical 2. And for distance AC, we got 20. So let's go ahead and do that. Put that on here. So we have 10 radical 2, we have 10 radical 2, and then we have 20 as our hypotenuse. Okay. All right. So we found our distance, we labeled our triangle. Now we need to figure out or make an educated guess which of the angles A, B, or C is going to form a right angle. Well, as you look back or step back, it looks like angle B is the closest to a right angle. So I'm going to use that as my right angle. So that little box here indicates that it is a square, and which indicates that it's a right angle, which is 90 degrees. Okay. Okay, so now I need to apply the Pythagorean theorem to calculate or determine whether this is a right triangle or not. Okay. Now it doesn't matter what you put for the side for A and B in the Pythagorean theorem, but it does matter what you put in for C. And again, C is the longest side of that triangle. Okay, so so in this case, our C is 20. And again, if you don't, recall or remember it's always directly across from the right angle. Okay, that will be the longest side of the triangle, and vice versa. The longest side of the triangle will determine to the opposite angle. That's the right angle. Okay. All right, so let's go ahead and plug this information. So A, we have 10 radical 2, and we also have 10 radical 2 for B. So A is 10 radical 2 square, and then 10 radical 2 square. Okay, and then C is our longest side, which is 20. Well, that's what we're claiming. Okay. Okay, so this 10 radical 2 square means I write 10 radical 2 two times. And then 10 times 10 is going to give us 100. And then radical 2 times radical 2, okay, that's going to give us radical 4, which is just 2. So we'll have 100 here times 2. So that's going to give us 200. Okay. And this is exactly the same thing for this 10 radical 2, so we don't have to go through the whole process again. We'll just say that that's 200. And then down here on the right is 20 squared, which is going to be 400. Okay, so 200 plus 200 is going to be 400, and that's equal to our outcome of 400. Okay, so the question is, what does this mean? This means we have a right triangle. Okay, for any reason, for some reason or any reason that these are not equal, then we say it's not a right triangle and we stop. Okay, we don't move on. Okay, but if they are equal, then that indicates that this triangle is a right triangle. Okay, so we have determined that it is a right triangle, and so our very last step is to figure out the area of the triangle. So the area of the triangle is A is equal to 1/2 times base times height. Okay, so what do we do here? Well, let's go back to our graph here. So when we find the area of the triangle, what we want for the base and the height are the numbers that are attached to that right angle. So in this case, it's 10 radical 2 and 10 radical 2. So they're attached to that right angle. Okay? So those are the two numbers I'm going to use to find the area of this triangle. So we're going to have 1/2 times 10 radical 2 times 10 radical 2. So 1/2, I'm going to multiply the ones without any radicals together. So that's 10 times 10. And then I'm going to multiply the ones with radical. So that's radical 2 times radical 2. So 1/2, 10 times 10 is 100. And radical 2 times radical 2, okay, that's just going to give us 2. Or we can say this is radical 4, which is 2, okay? Right? So notice that the 2's here are going to cancel, and then we're left with 100. So that would be 100 square units. Okay, so just to recap, what we wanted to do in an example is to show whether this triangle is a right triangle. So again, the first step was to plot each point and then form our triangle here. Next step is we need to calculate the distance of each side of the triangle, and we do that by using the distance formula. And so that's what we did here. We calculate distance of AB, that calculate distance of BC, and calculate distance of AC. Once we've shown that this is a right triangle, okay, and how do we do that? And that's through the Pythagorean theorem, okay? So that's what we're going to be doing next. Here is step 3. We did the Pythagorean theorem. So we have a squared plus b squared equals c squared, right? And we want to show through the Pythagorean theorem if they're equal or not. In this case, they were. So this means that it's a right triangle. Then we go to the last step, and that is to find the area by using 1/2 times base times height. So again, what we use for the base and height are the ones that are attached to that right angle. Okay. So after we put in the information that we obtained from the triangle, then we solve this, or in this case, um, simplify this, and we get that the area is equal to 100 square units.